Welcome back, everybody. What we're going to be doing today is solving systems of equations using substitution. We have previously watched a video on how to solve systems using graphing. Now we are going to substitute. Just remember, a system of equations is just me giving you more than one equation, and I want you to tell me where do they cross each other? Where do they intersect? So for example, these two equations below, we want to know where in the world will they end up crossing each other on a line. I want to know that specific point. That's what it means to solve a system of equations. We're going to use the substitution method. So you have to know what it means to actually substitute. Just like a teacher can have a substitute. So if I ever leave for a day, someone else will take my place. And it's the same thing. So if I have, say, Mr. Metz comes in and he takes over for the day, he is my replacement teacher, so he is a substitute. It's the same thing with variables. So if two things are equal to each other, one can take the place of the other. I want you to pause the video here and write all of this down. These are just the steps to solving a system of equations using substitution. There's quite a few steps, but it's pretty common sense once you see an example. You're gonna go, oh, okay, that makes sense. So write all of these down, make sure you pause the video. These equations here is example 1. I have y equals 4x plus 2 and 2y plus 8x equals 20. Remember, step 1 said that you need to get a variable by itself in either of the equations. Well, if you notice over here, we already have a variable that's by itself. The y is already alone. That's a good thing. That makes things easier on you. So I'm just going to highlight it. Y is already alone, which means everything that it equals, 4x plus 2, can be substituted or take the place of the y variable in the other equation. All of these values equal each other. They're the exact same thing. So I'm going to take this 4x plus 2 and plug it in or substitute for the y variable in the other equation. And then we're going to solve that. So instead of 2y, we're going to have 2, and remember, always put parentheses around whatever you substitute. We're going to do 2 times 4x plus 2. And then we still have that plus 8x equal to 20. So just notice how I removed this y over here and put 4x plus 2 in its place. Then simplify. So don't try and move things around until everything is simplified. We're going to take this 2 outside of the parentheses and multiply it by everything on the inside of the parentheses. So 2 times 4x gets me 8x, and 2 times positive 2 gets me positive 4. And then we still have that positive 8x equals 20. There's still things that you can simplify. We have x's on the same side, so we have 8x and another 8x. Both of them are positive. So we can go ahead and combine our like terms here. 8x plus 8x gets us 16x. And we still have that plus 4 over there equal to 20. Now we can go ahead and get x by itself. Start moving things away from the variable x. We now want to get x alone. So we're going to get rid of this plus 4. In order to get rid of an adding of 4, we're going to do the opposite and subtract 4 from both sides. So if we subtract the 4, well, 20 minus 4 gets us 16. Now we have to get rid of the 16. We want to leave the x behind though. So this is 16 times x. So to undo that, we are going to use division. Well, 16 divided by 16 is 1. So we have figured out what our x value is. But remember, when we are solving a system of equations, we need a point, which means we need an x value and a y value. So right now, this is all we know. We have no idea what our y value is. Where do our lines cross each other? Well, we know they're going to cross at an x value of 1, but what in the world is y going to be? So we have to substitute this number now back into our equation over here. So anywhere we see an x, I am going to put a 1 instead. And it does not matter which equation you use. So you could put it in here or here. There is definitely an easier one to use. So I'm going to give you a second, pause the video, think about which equation would be smartest to substitute the x into. Which one's going to give you the least amount of steps? If we substitute it in here, we would have to get x by itself, we'd have to get y by itself and start moving things around to figure out what it is. Here, y is already alone, so if we substitute in for x, it's just a one-step equation. So that's definitely going to be the easier method. So let's go ahead and do that. So I'm going to use that top equation. Instead of x, I'm going to put 1. And then let's solve. Well, 4 times 1 is 4. And then 4 plus 2 is 6. So we just found that our y value is 6. So that means these two lines cross each other at the point 1, 6. And we figured that out using substitution. Let's look at another example. This one here, you'll see though, has x as a lone variable. So you don't actually have to do step 1 in those series of steps. So I'm going to highlight all of my x's here. Anywhere you see x, they are equal to each other. This says x is the same thing as 8y, which means all 3 of these items can be swapped out for each other. Well, I don't want to swap out x for x. That makes no sense. It's not going to help us. I'm instead going to put this 8y into x. I'm going to use that as my substitution. So I'm going to rewrite that second equation, but instead of x, I'm going to put 8y. I put parentheses around the 8y because whenever you substitute, you should put parentheses. In this specific example, they're not actually necessary because there's no multiplication step going on that you need to make sure you do first. So I'm just going to go ahead and remove the parentheses. They're not necessary. We can go ahead and move forward with the simplifying steps. So here we have 8y minus 4y. They both have a y variable, which means they're like terms, and I can combine them. 8 minus 4 is 4. Leave that y attached. Now we want to get y by itself. We want to get rid of the 4. Well, it's 4 times y, so we would undo that with division. So what is 12 divided by 4? In this case, it gets us 3. So just like earlier, we have one of our variables, but we don't know the other one. So we don't know what x is right now, and we need to find it. So we're going to substitute again. We're going to take our value of 3 and plug it in for a y variable. Again, it doesn't matter which equation you plug this into, but there definitely is a smarter option. So here's our y variables. Think which one is going to be easier to substitute into. What gives you the least amount of steps? So I'm going to use the first equation and plug in there. So we have x equals 8 times 3. Because instead of y, we found that y and 3 are the same thing, so I'm going to substitute it in. Well, what is 8 times 3? You should get 24. So the points here, x is 24, y is 3. So these lines would cross each other at 24, 3. All right, let's look at another example. This one here, again, gives us a variable by itself. Y is alone. So let's go ahead and highlight everything that y is equal to. So we have a y here, we have a y here, and this is what y is equal to, which means all 3 of these things are the same, which means one can be swapped out for the other. So I'm going to put this 20 minus 2x into the second equation. That is the one that I'm going to copy, second equation. So we have 6x minus 5, but then instead of y, I'm going to put that 20 minus 2x there. This one's a little weird because when I distribute, you have to be very, very careful because this is technically a negative 5. Do not distribute a positive 5 or you are going to get an incorrect answer. So we can write that 6x down and then do negative 5 times 20. So this is going to get us a negative 100. Then when we distribute, we're going to do a negative 5 times a negative 2x. Remember, two negatives make a positive, so negative 5 times negative 2 is a positive 10x. So just be careful about that. Subtraction signs are kind of like negatives. Keep them glued to the number. Then we can combine like terms. So we have x's over here, a 6x and a positive 10x. So we can go ahead and add those. 6x plus 10x gets us 16x. And we still have that minus 100, and that equals 12. Now we can get x by itself. So here, let's get rid of this minus 100 first and do the opposite. So let's add 100 to both sides. If we do that, we get 112. The last step in order to figure out what x is to divide by 16, because right now what's 16 times x? So let's undo that with division. So in this case, I will get x equals 7. So now we know our x value, but we do not know our y value. So let's plug in what we do know in order to figure out what we don't know. So I'm going to put 7 in for my x variable over here. Again, it doesn't matter which one you plug it into, but the one where the variable alone is definitely the simplest method. So I'm going to use that first equation. Y equals 20 minus 2, but instead of x, let's use 7. Well, right now, this is a negative 2 times 7. Well, negative 2 times 7 is negative 14. And what is 20 minus 14? You should get 6. So we found that in order to solve these systems using substitution, these lines cross each other at the point 7, 6. All right, for this final example, I am going to show you how to get a variable by itself, and then I want to see if you can actually solve it. So right now I don't have any variables alone. I have x's and y's. They're not singled out, so how do we get them singled out? I'm going to look at the top equation. That one looks the easiest to work with, like it has the fewest amount of steps. So I'm going to try and get a variable by itself up there. So we have negative x plus 2y equals 4. And I'm going to attempt to get, let's see, x by itself. So in order to do that, we have to move the y to the other side. You are not going to divide then because we want to move the variable with it. So let's just subtract 2y from both sides. 2y. So I just moved the 2y over. Now right now this is a negative x that is like a negative 1x. In order to get x by itself, we are going to divide by negative 1. We have to divide all of this by negative 1. So I'm going to put kind of parentheses around this to show you that everything is going to get divided. So x will be by itself. So you have to do 4 divided by negative 1, which is negative 4, and negative 2y divided by negative 1, which turns into positive 2y. So go ahead and pause the video here because I'm going to give you the answers and see if you can take this here, since I've singled out a variable, and use it in the other equation to figure out what point do these equations have in common. So go ahead and pause it because the answers are going to pop up.